There
Okay,
we go.
hopefully you can see all of that. So my presentation it'll be on a study which was into the impact of smart motorways to carbon. So this was a study I did just over a year ago now. So when the study was done, it was slightly more topical than it might be quite now, before sort of the pause was put on smart motorways. But I think the impact and the outputs for it was still quite interesting. So a little bit of background to the project. So the project is the National Highways project, and it started off with a very simplified task. So it was task 3, which was the sort of the very basis of it, which looked at basically like a sort of dummy network within Vism, which is sort of a micro simulation piece of software. Which all we did, it didn't represent any particular road, it was just represented a motorway, and there'd be a case of smart motorways and non-smart motorways implemented on it. That showed some interesting results, and so we then expanded that to look onto an actual smart motorway section on the M62, which you can see in the figure on the bottom left there, between sort of junctions 10 and 12, just outside Manchester. So the project has a sort of methodology. So the first step of the project was really sort of collecting all the data, and because, as I'll go into a bit more detail later, but the level of validation we wanted our model to be in was very high. And so we collected as much data as we possibly could. So this included sort of halogen, Meadows, Entrant, NPR, anything we really could get our hands on. On top of that, we then used a program called FEM, which I'll again talk about later, to model the emissions that came out of sort of our Vism models, to give us sort of an idea of carbon emissions from them. I think on the side you can see there's a stage 4. So we didn't actually look into breaking emission modeling. However, I do understand there is some new guidance, and well, not necessarily guidance, but some new sort of reports being released on this. So it might not be as important as it was a year ago, but I think it might be quite interesting to look at in the future. So to give an overview of the model, so as I mentioned, it was all done in Vism, and so this was because we wanted a microsimulation model. It was easier to sort of represent the changes in speeds and flows of how a smart motorway might impact changes. The reason we chose this area of the M62 was because smart motorways opened in January 2021. And what this meant was that we had a lot of data, not only since 2021, but also data previously to 2021. So we could sort of compare data between the smart motorway operation and non-smart motorway operation. And so it allowed us to create, well, as I mentioned, we allowed us to create 2 models in the end. But for the main model, it was a June 2022 base model. So this was sort of with smart motorway in operation, but also sort of given enough time since COVID to allow some sort of elevation of traffic levels again. In terms of some of the data gathering and analysis, so on this map you see there's all the different data points we collected. I think, as I mentioned, it was sort of lots of different types of NPR, Entrant, Meadows, halogen, all which gave us slightly different bits of information. It was quite important to be able to sort of cross-check them against each other to make sure that sort of the data we had was as accurate as we possibly could, because we wanted the model to be as precise as we possibly could as well. And so, of course, another important part of this data was sort of understanding how smart motorways operated, which goes onto this slide. So we looked into the data and sort of tried to understand if smart motorways operation, sort of when the reduced speed limit would come on, and that would be at certain speeds of traffic that it would notice, or certain flows of traffic levels. However, as you can probably see, we didn't actually observe any sort of pattern within this. Instead, it was sort of seemed to be sort of at a certain time every single morning, a 60-mile-an-hour limit or 50-mile-an-hour limit, whichever it was at the time, would just turn on no matter what the sort of behavior of the road was. And so that's what we replicated in the Vism model. We saw when these speed limit changes occurred, and we could also verify that within the data. You could see that after a certain point, speeds of all vehicles would, well, not all vehicles, but the majority of vehicles would reduce. And so we've used that to kind of clarify within the model what timing of change points we would need to choose. Now, of course, model validation probably isn't the most interesting part. However, I thought it might be interesting because we looked into a bit more of detailed model validation. So instead of just the standard sort of the travel time and flow calibration, we also looked into lane usage. So this was using Meadows data, which provides lane usage for each. We could then extract that from the Vism model as well to try and get an as accurate sort of comparison as possible. top of lane usage, we also looked at site speeds. And so these are different sites along the, I think these are different Midas sites along the, oh no, WebTrist sites, I think actually, along the M62. And so yeah, we compared the model speed against that, and of course other index sites, index points as well. And again, this is all to try and get the best possible validation of the model, so that when we sort of convert it from, well, in 2022, it's smart motorway operation to a non-smart motorway operation, we're to be as confident as we possibly can be that what we're seeing is what would happen in real life. On top of that, we looked at some journey time variability, and this was mainly just to understand how confident we are with how sort of reliable the model is. And as you can see, all of those values there are very low. So it just showed that the model is very consistent in the runs, and the outputs you're getting from run 1 to run 10 aren't going to be too much difference between them. Now, as part of this project, we produced a counterfactual model. Now, that sounds a bit of a wordful, but the idea behind it is really to understand that if we have a base year, which is smart motorway operation, there is a bit of uncertainty, and if you remove that smart motorway operation within VISM, would it still calibrate, hopefully that makes sense, to sort of a 2022 base year without smart motorway? And so the way we sort of looked into this is we had 2016 data from WebTrist for June 2016. And so we created a second base model for June 2016. And so of course this base model didn't include smart motorway operation. And so we validated that model to that data and then applied smart motorway operation to it. And this sort of gave us sort of both ends of the stick as it is to understand the actual impact of smart motorways. And if there's similar impacts across both base models, I think it would give us a better idea of if what we're modeling is the correct way of looking at it. So to then convert the VISM outputs to sort of an actual answer, and then in terms of emissions, we use a program called FEM. Now FEM is an instantaneous visual emission model, and it produces second-by-second fuel consumption and tailpipe emission results. As you can see, it contains two main inputs, which one is the microsimulation outputs from VISM, and on top of that, you have vehicle fleet information, which is vehicle classes and such forth. FEM includes lots of confusing calculations and things, and is developed by, I believe, an institute in Germany. I can't quite remember. Well, I would try and pronounce the name, but I'd probably butcher it, so I'll probably best move on from that part. In terms of the vehicle fleet, we updated the VISM models based data within VISM to the observed data on the route, as well as sort of national averages that we could see. And so this was updated for each of the main vehicle types within VISM that we were looking into. Yeah, and then of course, and in terms of the microsimulation outputs that FEM is interested in, you can see some of them there. So it's mainly speed, the type of vehicle, and the gradient of the road it is on. To process the VISM outputs, it required a little bit of processing before we moved it to FEM. This was all done doing R, and the main one really was FEM outputs. FEM works in second by second. Now, you can get outputs in VISM by second. However, the amount of data that would require and the amount of time the model would run for that to happen would probably take a very, very long time. And so what we did it in 5-minute intervals and then converted those into per second outputs, as we believe 5-minute intervals would give us a high enough level of accuracy. And then from that, FEM takes in those inputs and produces outputs, which gives us something a bit like this. So this is the 2016 base year model. So this is the base year model that did not include smart motorway operation. And hopefully you can see in bold that if you look at the CO2, there is a 10% less amount of CO2 emitted with the smart motorway operation compared to the 2016 base year. And interestingly, I think if you also look at the total travel distance right at the bottom, you can see that not a major increase. However, we're also reducing congestion on the network in the smart motorways, and so we're getting less carbon, but also with more vehicle miles, which is quite a big bonus. And across the 2022 sort of outputs, we had a very similar output. So with our 2022 smart motorway sort of base model, we then saw, again, it was a 20% decrease in that model compared to converting that to a non-smart motorway in CO2. And again, if you look at the total travel distance, again, that's a bit of a bigger difference. So we're alleviating a lot of congestion on the network in that case, while also still reducing CO2 emissions. So of course, when this project was done, the impact of this might have been slightly more important. But of course, since then, smart motorways and the idea of them clearly not safe, which I think is the main thing. But I think despite that, I think what this sort of analysis has showed is that if you can sort of calm the traffic on a motorway and such that you can sort of reduce sort of the braking and congestion that it causes and can sort of produce a more average cross speed, you're going to allow more vehicles to travel there across the same period of time. Well, you're also going to improve your carbon emissions because you'd be traveling at more efficient speeds. And so I think if you take the outputs looking at that way, I think it still shows there's still probably quite could be done in the future in certain motorways, especially where in busy times that sort of variable speeds could definitely be used. However, I think that is everything. And if there's any questions, just ask.
Thank you very much, Tom. Yeah, certainly an interesting take, totally, with the carbon production on motorways in there. I'll have to see if any of our other judges have any questions first.
I noted a few down, but I'll just pick one of them. So you talked about like time efficiency and there being less congestion on the motorways and things. How much do you think like modal shift should be more important than like reduced congestion and that type of thing? Like, would it ultimately just encourage more people to drive if there's improved flow on the motorway?
That's a good question. I guess the issue with motorways is I guess the modal shift would then be onto sort of trains. And so encouraging people to use trains at the moment, I think, is quite a challenge. But I think that is a good point, is you do want to be wary of making motorways too, well, you want to make them as safe as possible as well, but you don't want to make anything too pro car at the moment, because yeah, it will hurt in general, because if you can reduce the vehicle miles as well as keep traffic smooth, you'd see an even bigger reduction in carbon, I'd imagine. And so I think, yeah, it's a good point, but yeah, I think changing people's travel from motorways to another mode at the moment, I think if you're stuck on train, or maybe unless long distance coach can sort of come out of nowhere.
Cool, thank you.
Tom, thank you for a really good presentation. Obviously, you mentioned at the start that the sort of government views on smart motorways has probably changed since you wrote your report. The findings from your report, you said it was commissioned by National Highways. Have they used those findings productively, or I'm just interested, have they used them or have they parked them given this smart motorway situation? What's been done with your findings?
It's a very good question. Who knows what? So I think they were definitely, at the time we reported them, so I think it was about this time last year we sort of produced all this, and so I think they definitely took into the sort of the idea that sort of making a more free flow speed on the motorway as such, in terms of keeping everyone at more consistent speeds is better. How they've taken that since the news of smart motorways sort of being canned is I'm not sure. I can't say I've spoken to that team sort of since then. But I think it'd be interesting to follow up on.
Yeah, Tom, that was a very interesting topic. I really enjoyed that, and interesting data outputs from there. As we say, probably not of relevance at the moment, but I'm sure somewhere along the way somebody can do a full appraisal of all the costs and benefits of smart waterways. My question was really this, that I don't know if I missed what the composition of the vehicles were in your data sets, but I mean, electric vehicles clearly have a different emissions profile, and whether you took that into account or not, I just wondered if you had used the model in any sense to look at what the impact of increased EV or PHEV content would be and what kind of results flow from that.
Yeah, so for the fleet composition, we use sort of observed values as well as national averages. Well, we didn't do any future sort of projections on fleet composition, which is sort of I think what you're leaning on there. And that was mainly because we wanted to, well, we looked back at 2016 instead of doing future ones because I think we were wary of adding too much uncertainty into our analysis. But I think it is an interesting point because if you do add more EVs onto the roads, then the benefits you'll be seeing from that I was showing would be reduced. So because these are all the benefit, yeah, with electric vehicles, you wouldn't be having reductions in CO2. However, it does show that if you could reduce congestion of the network, it could potentially still be a benefit in that respect. So yeah, I think it would sort of the outputs would be less impressive on the CO2 side, but I think it still would show benefits into what the idea of Smart Motorways is trying to achieve.
Sure. No, thank you.
Wonderful. So I think we'll wrap it up there, Tom, looking at the time when we're coming up to time. So thank you very much for your presentation.